I'm Dr. Peter Dittmar. I'm in the horticultural sciences here up in Gainesville. My specialty is in weed science of vegetable and deciduous fruit crops. And so let's go ahead and get started to talk about weed management in our Brassica crops. So this is just a quick outline of what I'll be talking about today. The beginning of my presentation is going to focus on herbicides that are available. First looking at our head and stem, moving on to our leafy brassicas. And then after discussing herbicides, we'll talk about some of the systems management programs that we've done some research on, just so that way we can be managing our perennial weeds, especially nutsedge, so that way we can get not total weed management, at least management that we can control the weeds. So the first herbicide that I'm going to talk about is sulfentrazone. Sulfentrazone is a fairly old product, but they widened the labels for expanding it into vegetable crops. And this happened about 2 to 3 years ago. And so the first thing that I will say is that it is very important for you to consult the label for the sulfentrazone that you are using. And so the two examples that I have up there, now there's several different manufacturers who produce sulfentrazone, but I've only got two up here because these are the two extreme cases. The first one is Spartan FL 4F. Now, Spartan FL is registered only for cabbage transplant only. But then when you look at the next product, which is the same active ingredient, is sold as Willowwood Sulfin 4SC. And you can see that there's a lot more crops registered for Willowwood. So you've got a lot of the head and stem, the broccoli, cabbage, cauliflower, kohlrabi, and then all of our leafy brassicas as well. You know, the bok choy, kale, collards. I'm missing a comma there. That's kale and collards, and mustard greens. So you can see that. Consult your label. And this is where I will say that, you know, even though Willowwood is registered in multiple crops, you cannot spray Spartan on crops that are not labeled. So even though even though the business that you are purchasing the pesticides from only has the other product, it's off label. So that's just my extensionist saying stay on label. Where this fits in really well. Oh, one of the other reasons you should consult your label is because some of them have different formulations. So for Spartan FL, you're going to use 12 fluid ounces per acre, compared to the Sulfin 4SC is 2.25 to 3 fluid ounces per acre. So the Willowwood is just a little bit higher concentration, so you can use a lower rate. Where this fits in really well with our program is in the weeds that can be controlled: pigweeds, lamb's quarters, Florida pusley, sedges. All of the labels contain annual sedges. Some of the labels include yellow and purple. From the research that I've done in cabbage, some years we have really good control of nutsedge, and then other years we don't. We're still working out why there's some differences in our nutsedge control with sulfentrazone. And then there at the end is annual grasses are also included in all of the labels for control. So one thing that I want to put here is in the sulfentrazone label, they list the specific crops and instead of crop groups. So I just wanted to, take a brief second to talk about crop groups. So this presentation will be available later, so you don't have to get into into the details on this. I just want to show you that so all of our vegetable crops are put into various crop groups. So you'll see on that top line, we've got a group called the leafy greens subgroup. And so when we do pesticide registration, we can collect the residue and the tolerance data from the head lettuce and the leaf lettuce and the spinach. And so we can collect that residue data from those representative crops. So that way we can get everything that is in that group. Everything that's in this subgroup has a similar growth habit, similar production practices. And so this allows us to get products registered in a multitude of vegetable crops without having to do expensive residue studies on every single crop. And so that's the great thing, is that we can get a lot of pesticide registered for the variety of vegetable crops that we have. The downside to crop groups is that sometimes they'll register only they'll register the whole group, or they'll register only part of the group. So you can see the herbicide label on the left, that's glyphosate for a pre-plant burn down. And so we can see that in cucurbits, we've got every single cucurbit listed there on the left, because they're willing to say we've got crop safety in all of these. But if we look at the prowl label that's on the right, we'll see that there are some concerns for crop tolerance. And so even though we've got the residue data for that entire crop group, we just haven't documented the crop safety yet. And so when we see in a herbicide label or all pesticide labels that we've got the entire crop group, then we can do that whole crop group. But sometimes they'll specify the exact crops, and this is because of crop tolerance or crop safety concerns. So that's sulfentrazone. The next label I want to talk about is one that's I'm hoping will be available for this growing season, but let's be honest, it's moving slow. And so most likely it will be ready for next season, but I just want to make you all aware of what's coming down the pipeline. Goaltender. So this is a proposed 24C state label. You probably have seen a very similar label in other states. There's like 18 other states that have the 24C label that we are pursuing. What this label will be is a goaltender at 4 to 6 fluid ounces 2 weeks after transplanting, or if you've got direct seeded head and stem brassicas, you need 4 true leaves, so that's direct seeded. And so I've got some data here that we did on farm and at the research center, looking at oxyfluorophane or goaltender pre-transplant, the same day as transplanting. So we transplanted and then sprayed right over the top of them within 30 minutes of them going into the ground. 4 to 6 leaf stage, 6 to 10 leaf stage, and then what would it look like if we didn't treat it all? So if we look at 30 days after planting, so that second column, we can see that and this is lamb's quarters control. Sorry, so this is the control of the lamb's quarters. We can see that we got excellent control at transplanting and pre-transplanting, and it was very similar to the post. But what we get is, later in the season, we can see that 63 days after planting, we still have really good control from a post-transplant. And this is the worst of the 3 studies that we did. Now, when we look at cabbage injury, we can see that, later in the season, we do have quite a bit of injury when we sprayed it in the fall. So it's that second column there. We're looking at 7.5 on a scale of 100. So it's really minor. And all of that injury is occurring on the wrapper leaves. So this is this is the weed control study that we did. On the far left is the non-treated. So you can see all of the lamb's quarters that is popping up on the sides of the bed. There in the center is our pre-transplant application, and it's really hard to see it in the picture just because it's a green weed growing on a green crop. But those little red arrows are showing all of the lamb's quarters that has broken through just because it's later in the season. And then on the far right is the 4 to 6 leaf stage. And you can see, so we only sprayed that center row. So if you look on either side of that plot, you can see that we did have a really good stand of lamb's quarters in that field. So this is the goaltender injury that we saw. On the far left is the 4 to 6 leaf stage. You can see that the injury occurs as burning on the leaves, and so that early application is on those leaves that are going to probably fall off as the season goes along. And then on the right, this is the sort of injury that we saw on the leaves that are at 6 to 10. There is some concern about the delay of harvest. The 4 to 6 leaf stage caused a 3-day delay in harvest. So there was no difference in total yield and no difference in the head size, but that's because we harvested when they were at market weight. And so some plots had to be harvested that 3 to 4 days before or 3 to 4 days after the non-treated. So that's just something to be aware of when using goaltender post-emergence. So what I just showed were 2 products that are new to the Brassica group, sulfentrazone and oxyfluorophene. And even those AIs are not new active ingredients. They're just new to the crop. And a lot of that is just because there's not a lot of exploration in herbicides in vegetables. So one thing that we need to do for weed control is that we need to not only do weed control in the crop itself, but also do some weed control during the fallow period. And so the next 2 studies that I'm going to show you is weed management that we can do during the fallow period. So the first experiment is to look at a really long weed control fallow period. So this is 4 months. What we looked at is a cover crop using sun hemp, cowpea, sorghum, and sun hemp, cowpea, and sorghum Sudan grass. And then we were interested in knowing whether or not using S-metolachlor or dual at 1/3 of a pint would reduce the amount of weeds early in the season when your cover crop canopy hasn't completely closed yet, hoping to get that additional effect of a herbicide along with a cover crop. Then that 3rd treatment is glyphosate. That's a 24 fluid ounce glyphosate rate that we're using. And we did that twice using an 8-week interval for those 2 applications. And then using a non-treated weedy fallow. So no cover crop, no herbicides. So like I mentioned, this is a really long fallow period. We planted the cover crops on April 18th. We terminated the cover crop on August 18th. And then for this experiment, we used bok choy, which was planted in October and then harvested in December. So if we look at, so what we were most interested in was the control of nut sedge. We can see that our various cover crops are on the far left. Whether or not we used a herbicide in that fallow period. So we planted on April 18th. When we did an evaluation on June 17th, we didn't see any differences between our treatments. So we expected to see that early weed control from the herbicide, and we just didn't get it. By the time we mowed and then allowed the nutsedge to, we mowed and we allowed that cover crop to break down a little bit. And so we did see a really excellent effect in that our cover crops didn't control our purple nutsedge very well. So you can see that in the cover crops, we had anywhere from 41 to 50 nutsedge in 2 square feet. Compared to the 2 applications of glyphosate, we only had 2. And then once we planted and got halfway through the season with the bok choy, again, the best weed control that we got was from the 2 applications of glyphosate. So this is just a quick example of what we had for our cover crops. In the far left is the sorghum. We didn't do any sort of fertilizer, which in hindsight was a bad idea because you can see how yellow it is. The sun hemp and the cowpea are there in the center and in the lower right. Looking at some pictures, glyphosate is there on the left. And then on the right is the sorghum. What is a little hard to see in this picture is just that the sorghum, the nutsedge in the sorghum has gone to flower. So you can sort of see a purple tinge that is occurring in that field. And then some of the conclusions that we can come to, I know I'm coming up on time, so is we didn't get the sort of control that we wanted from the S-metolachlor. Some of that may be the fact that we waited. Our sorghum wasn't concept treated, so we weren't able to apply the same day as planting, so we had to delay our application. And so this is just showing that application timing is important for that weed control, because we've tried this study in other places and we've gotten better weed control with S-metolachlor at the time of planting. And then one of the other things is that our weed pressure was just so high that we couldn't get any yield differences in our nutsedge. You know, in our fields at the research center that we have in Citra, you know, we had 50 nutsedge in a square foot. So it's definitely worst case scenario. And so even in our non-treated, it didn't work really well. Okay, so I showed you the 8 months, or not 8 months, but 4 months was just way too long of a fallow period. So what can we do fallow period? So we looked at a non-treated, again, what if we did nothing, using a tine weeder, which is in the upper right-hand corner. Those tines are about 3/4 of an inch wide. The S tine is there in the center, and those tines are about 1.5 inches wide. Lower right-hand corner is a rotavator. And so those blades just tear up the nutsedge that's in the field. And then we also used a cover crop as well as, again, the glyphosate, 2 applications of glyphosate. So this is just how it looked. We cultivated the entire field at 0 weeks. Then the weekly cultivations, the biweekly applications. The glyphosate here was applied at 3 and 6. And then at 7 weeks, we mowed the entire field and then prepared for planting the bok choy. So this is our nutsedge counts. And so you can see at the very beginning of the fallow period, we had all of the treatments were similar. Once we got here to the 3 weeks, we can see that our non-treated is really, really high. But we are getting really good control from the tine weeder as well as the glyphosate. But this glyphosate is when we did the first application. So you can see that we have a large decrease. And by the time we do a second application, we're all the way down to less than 3 in a square foot, which is very similar to a rotavator and the S tine. The weeds just got too big for the tine weeder to do very well. So you can see that the tine weeder is way up here with the non-treated. So going into the bok choy. So this is the cash crop. Again, I'm just going to skip right to the 14 weeks at the very end of the season. You can see that tine weeder, again, is even worse than our non-treated, but we still get really good control from a rotivator, an S-tine, and a glyphosate application. And you don't even have to do the rotivator every single week. You can just do it at a 14-week interval, which is really great because that nut sedge is able to emerge. You can use up that carbohydrate that is in that tuber, but that 2 weeks isn't enough for the nut sedge to produce daughter tubers and make the problem worse. Just some quick photos. This is 10 weeks after the initiation of the experiment. So this is 10 weeks. And then later in the season, you can see the 14 weeks. So this is about near harvest. I didn't cover the data for the broadleaf weeds just because of time, but you can see that it didn't work very well on broadleaf weeds. And that's my time. So I'll stick around. So if you want to put some questions in the chat, I can take them there. So.
Yeah, so my focus, I'm a nematologist, my focus is really on vegetables and small fruits. We've done a little bit of work on cabbage, but it's really has not been one of our main crops. So let me get started. Just a little bit of background. Nematodes they're often called the unseen or invisible enemy because they're often not recognized by growers. Because they do their damage below ground. Their symptoms above ground are not very typical and often confused with other problems. And of course, they're microscopic. So this is what a typical nematode looks like. It's a microscopic, long, thin, round worm. The typical feature for a plant parasitic nematode is this stylet at the top of the head. It's like a spear or a hypodermic needle that the nematode uses to pierce plant cells, root cells, and feed itself. So it's a fairly complex organism. It has a reproductive system, digestive system, even a small nervous system. Let me go back here. I do want to point out that when you think about soil, there's definitely a lot of plant parasitic nematodes, especially in agricultural soil, but still the majority of nematodes in your soil are not going to be plant parasites. The majority are going to be nematodes that feed on bacteria, on fungi, or on other nematodes, and they all play an important role in the whole nutrient cycle process in your soil. So keep in mind that nematodes are the most abundant multicellular animals on the planet. So, any bit of soil, any handful of soil will typically contain hundreds to thousands of nematodes, mostly beneficial. Just to give you an idea, the size, as I said, they're microscopic, but there is some variation in size and length. They're all very thin, so that's why they're pretty much invisible. But the size, the length pretty much varied from a 1/4 inch for the largest nematodes, like Longidorus, Dolichodorus, Belonolimus, to 1/60 of an inch for the smallest nematodes. Also notice that some stages of nematodes are no longer worm-like, but they become kind of almost round, like in case of root knot and cyst nematodes. On top of that, let me go back here. On top of that, you see a tip of a pencil, just to give you an idea of the relative sizes of these different nematodes. It's also important to realize that nematodes feed on roots in different ways. The most damaging nematodes are often endoparasitic, means the nematode completely enters the root system. And you can see that on the transect of a root on the left, these round nematodes like root knot and cyst, they develop completely inside the root. Other endoparasites like lesion nematodes, they keep their worm shape, but they will also completely enter the root system. Some are semi-endoparasites like reniform and citrus nematode, they only partially enter the root. But really the majority of nematodes, plant parasitic nematodes, are ectoparasites, so they will just feed on the outside of the root like sting, stubby root, ring, and dagger nematodes do. So as far as co-crops, I've listed here the most important nematode pests. Globally, the number one nematode on Brassica crops is probably the sugar beet or the beet cyst nematode, Heterodorus cacti. It's an endoparasite. Root knot nematodes are important parasites of Brassica crops as well. They're also endoparasites, as well as lesion nematodes, Pratylenchus species. As far as ectoparasites, the most important ones are probably stubby root nematodes, and especially in Florida, also sting nematodes and all nematodes. All and sting nematodes are very similar. They're related genetically. So those are ectoparasitic nematodes. I'm going to talk a little bit more about some of these different nematodes. As I said, globally, the beet cyst nematode, Heterodorus cacti, is the most important. This was actually one of the first plant parasitic nematodes that was ever discovered around the same time that root knot nematodes were discovered. Beet cyst nematode was first found in Germany in 1859 on sugar beet, and it really caused a lot of havoc to the sugar beet industry. Dozens of sugar beet sugar factories around that time had to be closed because of this nematode damage. This is more specific. It doesn't have an extremely wide host range. It mainly reproduces and causes damage to beet crops, to brassica crops, and chenopodium crops, which is like spinach. It's one of those. In Florida, we really have only found one report of this nematode on cabbage going back to 1970 by Harlan Rhodes. Other than that, I haven't found anything. So I don't think this nematode is really a problem in Florida. It is quite a big problem in California, especially in the Imperial Valley, where they have a long history of sugar beet production, and it causes a lot of damage on brassica crops grown there in the Imperial Valley now. So if you look at the global map, you see it's got a worldwide global distribution, but mostly in more temperate regions. So it's not very common in the tropical regions of the world. So this is more a type of nematode that prefers temperate climate conditions. You can see the picture here on the top. It's the cysts that these nematodes form on the outside of the roots, which start out as white and then they turn brown, but they can be pretty easily seen with the naked eye. So root knot nematodes, this is by far the most damaging nematode worldwide, and certainly also in Florida. It's very common in our state. We have more than 15 species. These nematodes have an extremely wide host range. There's actually very few plants that will not get damaged by this group of nematodes. There's a lot of interactions with soil pathogens. In Florida, we have interactions with root knot and fusarium in tomato that are quite common. In cotton, there's interactions with verticillium wilt, just to give a few examples. There's probably a lot more interactions that we're not aware of at this moment. And of course, they typically form these galls or knots on the roots, as you can see on the picture, that tomato root on the right. The life cycle is, it's an endoparasite. So you have these juveniles that move around in the soil. Once they enter the root, they become sedentary. They're not going to leave the root anymore, and they turn into these sausage and eventually pear-shaped females that produce these big egg masses containing hundreds of eggs. The life cycle in Florida for most root knot is about 3 to 4 weeks. So, you can get multiple generations in one crop. This is some damage from root knot on cabbage in Florida. This is from a colleague of mine, pictures from Zane Grabau, who's a nematologist up in Gainesville in our department. But it shows you the typical symptoms that nematodes will cause, especially root knot nematodes on crops. So you see these stunted cabbage plants, kind of patchy. It's not very uniform in the field. When you look at the roots, you can see the galls, the knots on the roots. Late season, you can see some yellowing, some mild chlorosis on some of these brassica plants, and just basically, stunted plants due to severely reduced root system. So these plants are just not effective anymore in providing the plant with water and nutrients. Sting nematode, Melonolinus. This is a very important nematode in Florida, especially in our sandy soils. It's really a true Floridian nematode. If you look at the global distribution, it's mostly the US, and in the US, it's really also mostly the coastal plain soils, like the sandy soils, where we find this nematode to be quite common. Some of these other countries where it's been spread, likely with infested salt coming from Florida. It's an ectoparasitic nematode. It's a large nematode. It's got a very long spear stylet, so it can do a lot of damage to a small root system. It's one of the main problems in strawberry production in Florida. It causes these stunted, small strawberry plants, and it really does a lot of pruning on these small roots. So you have these stunted plants that you can pull out without any effort because the roots are pretty much completely gone. It's got a very wide host range. I mentioned strawberry, but it can also cause a lot of damage to vegetables, to citrus, to a lot of field crops like corn and peanuts. Turf grass, sting nematode is one of the main problems there as well. We still consider this nematode a single species, but there's definitely a great deal of diversity in morphology, host preference, and genetics. So likely this species is actually different species. It's a species complex, but we haven't done really much work on that. This is some damage from sting nematode nearby. This is an organic farm here in Waimama, growing broccoli and cabbage from a few years ago. Again, you can see the stunted plants here on plastic on the left. These plugs, broccoli plants, they never put out any roots. You know, as soon as they put out roots, the sting nematodes will attack them and they just stop growing. So the plants pretty much never grow. Interesting in this field, and this is just observational, this was not an experiment, but while we saw quite a bit of stunted, patchy areas in the broccoli beds, there was some cabbage beds rows nearby that looked almost normal, you know, where the damage was much less. So possibly there is some difference in susceptibility among different brassicas, and definitely looked like broccoli was more susceptible or sensitive here than cabbage. So a little bit about nematode management. I always advise people to use an integrated approach, and this is a simplified chart from this new book that came out recently on integrated nematode management, which you can download for free. I put the link on there from the Cabbage website, so you can download the whole PDF of this book for free. There's a lot of chapters on from all places around the world focused on specific crop nematode situations, several from Florida as well. But basically, integrated nematode management is there. We look at it as based on 5 pillars, basically. One of them is crop rotation, which includes cover crops. Another one is cultivar choice, which includes resistant cultivars. Unfortunately for brassicas and cabbage, I'm not aware of any nematode-resistant cultivars available. I think there may be some that have resistance against this beet cyst nematode, which is not an issue for us. Soil management is another pillar. You know, in our sandy soils, adding organic matter is always a good thing to stimulate the biology in your soil that may help control some of these plant parasitic nematodes. Of course, targeted control, which includes nematicides, biological products, and then there's also monitoring and evaluation, which is important. So I'm just going to talk a little bit about some of the things here. This first is the list of nematicides that you can use in brassica and cold crops in Florida. This is from the Vegetable Production Handbook. So the fumigants are still available in brassicas. You can use products like Telone, like chloropicrin, metam-based products like Vapem and Kpem, and also Dominus AITC is available as a fumigant. As far as non-fumigants, MoCap, old organophosphate nematicide is still available. And then there's the new nematicides, Nimitz and Vellum, which have become more recently available to growers. As far as biologicals, I just want to mention Magistine, which is based on dead bacteria from Burkholderia, and Melicon, which is a live fungus, Purpureosylium. There's also several essential oil products that you can use as biological control. This table just shows you the nematicide profiles, the synthetic nematicide profiles, and I color-coded them to kind of indicate the relative safety of these products. Obviously, fumigants have a danger label. The same as MoCap, etoprophos, it's an old organophosphate, so it's pretty toxic as well. And the new products like Nimitz and Vellum are very different as far as safety. So they only have a caution label. They're very safe to the operator. So it's really nice to have some, for the first time really in history, that we have some actual nematicides that don't have a danger label anymore. I also want to point out that some of the physical properties, the solubility in water, the soil half-life is quite different for some of those products. For instance, fluoparem vellum is not very soluble, which means it's not going to move very well in your soil. But it does have a very long half-life, so it's got a long residual. It's going to hang around for quite a while, which is very different from some of these other nematicides that really don't hang around that much. These new nematicides also have new modes of action, which is obviously a good thing. In the past, we only had these cholinesterase inhibitors as well as the fumigants. So it's nice to see some new products, and I think we'll probably be seeing some more new products coming in the market in the next few years. Cover crops, this is part of the crop rotation pillar, is something that, I believe every grower should try to incorporate into his management system. Cover crops can help in nematode management because they are non-hosts to the nematode that you're targeting. Some of them can also produce toxic root exudates or breakdown products that help kill nematodes. And most of them will really increase the activity in the soil food web and stimulate some of these nematode antagonists that are common in soil. So what about cover crops and nematodes in Florida? So this is just a brief summary of some work that we did looking at the host potential of these different nematodes for cover crops. So as far as root knot nematodes, you will decrease your root knot nematodes when you plant sun hemp and sorghum sudan grass. So those are really good cover crops if root knot nematodes are your target. You don't want to plant sunflower. It will increase root knot nematodes quite significantly. And also cowpea tends to increase root knot nematodes, but with cowpea, it really depends on the cultivar that you use, as well as the root knot nematode species that you're dealing with in your field. Sting nematodes seem to decrease with sun hemp. We don't have too much data on it, but that seems to be the trend. So sun hemp's a good one for sting nematode as well. But you don't want to grow sorghum sudan grass if sting nematodes are a problem in your field, because they will increase with this cover crop. The same for stubby root nematodes. They really like to feed on sorghum sudan grass. And lesion nematodes, both sun hemp and sorghum sudan grass seem to increase these numbers. So basically, there's no single cover crop that will take care of all your nematodes. So one of the strategies that we're trying to look at now is see if we can mix some different cover crops and see how that influences the nematodes in the soil. It may be a better tactic to use mixtures as to not select for one specific nematode too much. Also, as I said, some cover crops may produce compounds that are toxic to nematodes. Sun hemp is one of those. We did some testing with sun hemp plant material, both root and shoot material, incorporated in some of these boxes, add nematodes and see how many survive. You can see that both below and above ground material really give quite a significant reduction in root knot nematodes. And we tested it both under aerobic and anaerobic conditions, and especially under the anaerobic conditions, we see a really significant decrease or nematicidal activity of the plant material, both root and shoot material. So that's another benefit that we see with sun hemp cover crop. I also want to mention that Brassica plants themselves contain certain allelochemicals. Now, most of the commercial cold crops, they've been selected to have low content of these allelochemicals because it kind of impacts the flavor, the taste, because these are sulfur compounds. So they may give a strong odor or sometimes, something that's not really palatable to people. But there's also some of these brassicas that now are being bred to contain high allelochemicals. So there's certain mustard varieties, certain radish varieties that are being bred as with a specific purpose for biofumigation use. So the background here is that all these brassicas contain compounds which we call glucosinolates. which is basically glucose molecules with a sulfur substitution on it. So they all contain it. These are not toxic in themselves, but when they break down, when they hydrolyze, and combined with the enzyme inside the plant called myrosinase, they produce a bunch of volatiles and toxic compounds. One of them is our isothiocyanate. So this is basically the active ingredient of products like K-PAM and VAPAM, as well as a bunch of other volatiles. So this is kind of the little overview of, if you want to use brassicas for biofumigation, how you would do that. We've done some work in the past where we planted brassica cover crops in winter. So you can plant your mustard, your radish in winter. Early spring, you mow them. They do really well in winter. You mow them, you rototill them in, apply some fertilizer, and then you irrigate them. It's important to add enough water because it's a hydrolysis reaction. You can build plastic beds on top of it to kind of trap the volatiles, and then you can plant your vegetable crop. In some areas, they have had pretty good success. I think in California, they have a system that works quite well. I don't think we've had that much luck with it here in Florida. One of the problems with some of the brassica crops, as I said earlier, is that they're actually good hosts to certain nematodes like wood knot. So while you grow the crops, you may actually increase some of the nematodes. Anyway, it's just something I wanted to mention that's an opportunity for some people. And then finally, and this is kind of a no-brainer, but I just want to mention it to finish, is that sanitation is really key with any type of nematode management. You have to realize that nematodes mostly spread passively, so they don't move too much on their own, only a few feet horizontally. So most of their movement is with soil water or with soil movement. So across fields, you may spread nematodes around through your, soil stuck to your tractor tires. If you get flooding events in or around your field, that's going to move nematodes around. And of course, across states and countries, some nematodes will be in tubers, potato tubers, sugar beet tubers. We found, occasionally or quite frequently, actually, we find nematodes in strawberry transplants that come out from out of state. So sanitation, making sure you don't introduce nematodes in your field is another key component. I think that's all I had. So I just want to point out some of this, more information on some of this you can find in some of these EDIS publications. I added a link here. One is in English, another one is in Spanish. And you can always shoot me an email if you have some additional questions. Thank you.
Thank you so much for joining this workshop. My name is Shinsuke Agehara, and I'm a plant physiologist at Gulf Coast Research and Education Center. So I'm going to be the first speaker in the nutrient management topic, and so I'm going to be talking about basics. And then the next speaker will be Dr. Zotarelli, and he's going to be talking about more specific information, nitrogen recommendation, and some updates based on his research. So I'm going to cover 4 items today, starting from soil testing, fertilizer recommendation, nutrient deficiency diagnosis, and tissue analysis. They are all important for soil nutrient management. And so soil testing. So when you send the soil to a commercial lab or a UF soil testing lab, you receive this type of soil report. And the amount of information you get will depend on what you request, of course. But if you request standard complete test, then you will have soil pH, macronutrients, micronutrients, and soil CEC. So soil pH is here. Macronutrients are normally listed on the top, then micronutrients, and then the CEC is here in this corner, in this case. And there are some optional tests, and one is organic matter, inorganic nitrogen, and soil texture. organic matter, inorganic nitrogen, and soil texture. So starting from soil pH, so 6.5 is the target soil pH for brassicas, and the brassicas are considered only slightly tolerant to acidic soil. So they don't like too much acidity. But the reason why Brassica prefers 6.5 is because when the pH is too low, you can see that this is the chart showing availability of different nutrients, and micronutrient, the availability becomes limited. And when the pH goes high, then availability of micronutrient becomes limited. So normally 6 to 7 is the hard spot, and 6.5 is right in the middle. So Brassica is safe to be, if you can get 6.5, that's very good. And soil pH is so important because it determines the availability of nutrients. So this is something you have to look at before you start to adjust other soil variables. Micronutrients. And this is the interpretation by IFAS for vegetable crop, and it's pretty universal across different vegetable crops. But one thing I want to note is that interpretations of soil test results, macronutrients, micronutrients, they are different from university to university, or there is difference between universities and the commercial labs. Okay. But here is the interpretation that IFAS developed. And for phosphorus, we considered when the soil test result is less than 25 ppm, it's considered low. Between 26 to 45, that's medium, and higher than 45, that's going to be considered high. And then the potassium, magnesium, calcium, and so on. And so I think this is, I think, relatively accurate, except for phosphorus. So phosphorus is a very tricky nutrient because the extraction of phosphorus depending on the soil test, and it's very difficult to find the optimum soil test. So recently we found that this interpretation might not be accurate enough for Florida soil. So there's a project going on to evaluate this interpretation and also the soil test itself. So this interpretation, especially for phosphorus, may change in the future. And we are working on that. And I hope we can provide more accurate interpretation in the near future. And all this information can be found from the link here. Micronutrients. And the micronutrients interpretation will depend on the soil pH. And here is the soil pH, and this is the list of micronutrient and interpretation, deficient, toxic, or deficient. So what this means is that in case of copper, when soil pH is between 5.5 to 5.9, if the soil test shows below 0.1 ppm, then that will be considered deficient. Then we will have to apply additional amount of copper. And the soil CEC, CEC is cation exchange capacity. And the cation exchange capacity is pretty much the indicator of nutrient holding capacity. So higher the better. And here is the interpretation. And when CEC less than 10, then we consider it's low, and that's typical for sandy soil. If it's 10 to 20, then we can consider it's medium. More than 20 is high. So the reason why our soil do not have a high CEC is because CEC really depends on the amount of clay and organic matter, because they are the ones that hold positive charges. They are the ones that hold negative charges, so they can attract the positive charged ions such as potassium, calcium, magnesium, and so on. And optional soil test, organic method. And you can include organic method in the soil test if you are using organic material in your fertilization program, such as compost. If you are not, you don't expect that the organic matter will change at all. So you don't really have to test organic method. And organic matter in Florida soil typically is pretty low anyway. But if you want to, if you are working on, improving the soil health by implementing organic practices, then organic matter is for sure a good soil variable to test. Inorganic nitrogen, and we typically don't have to test it before planting because of the heavy rain. Our soil do not have high enough inorganic nitrogen. So we pretty much consider that the soil do not have inorganic nitrogen at the beginning of the growing season. And when I test inorganic nitrogen at the beginning of the season, it's most of the time pretty low. So it's really not necessary, but you can test it at the end of the season if you want to evaluate your nitrogen program. And if you find really a high level of nitrogen, inorganic nitrogen, at the end of the season after harvest, that means the soil still has a lot of nitrogen that your crop wasn't able to use. So that might indicate that you are over applying nitrogen. So if you are testing nitrogen, testing at the end will give you more useful information. And the soil texture, this will not change over time. So if you know your soil, then you don't have to test it. But if you're curious, if you haven't done this test, you can include this test. And fertilizer recommendation. So for Brassicas, nitrogen recommendation by IFAS is 175 pounds per acre. And the phosphorus and potassium, they will depend on the soil test result. If the soil P is considered low, then you can apply up to 120, 150 pounds. If the soil P is considered medium, then you can apply up to 100 pounds. If the soil P is considered high, then we don't recommend any phosphorus. And the potassium, something very similar. Again, this might also change in the future because we are re-evaluating the accuracy of soil test for phosphorus and the accuracy of the interpretation. So this might change in the near future. Micronutrients, this is the general recommendation when soil test results are at deficient level. Based on the table in the previous slide, you can apply these amounts for different micronutrients. Next one, nutrient deficiency diagnosis. So, it's always the best if you sample the tissue and, test it by a commercial lab or a UF lab. But you can also do visual diagnosis by yourself as well. And here is kind of a general rule. The nutrient deficiency, depending on the nutrient, the symptoms are different and the location where symptoms appear will be different. So you can kind of follow this chart and then you can have some ideas what the deficiency may be. For example, if you find the symptom only on new leaves, then you follow here. And if it's necrosis on growing tip, or intervenial chlorosis, if it's necrosis on growing tip, and you come here, and then incomplete flower and fruit formation, or deformed leaf development, tip burn and carring. And if it's this, if this is the symptom that you are finding, and it's most likely calcium deficiency, something like that. So I know this presentation is recorded, so if you like to practice doing the visual diagnosis, then you can use this information. Okay, the last item is tissue analysis. And I just wanted to discuss important tips for tissue sampling. So first, nutrient deficiency symptoms can be induced not only by insufficient fertilization, but also by nematodes, stress, insect disease, and unfavorable weather conditions. So just because you're finding, for example, yellow leaves, it might not mean, nutrient deficiency, nitrogen deficiency, or you might see it could be nutrient deficiency, but the main cause is not because you didn't apply enough nitrogen. It could be because of the nematode damage that the roots cannot uptake nitrogen. So, you can do tissue tests to find out what's going on, but it doesn't tell you everything. When there are only a few random plants showing nutrient deficiency symptoms, the problem is likely not associated with your fertilization program. So, if you see the problem is patchy, then and then especially if you think that there is no problem with your fertilizer application or drip injection system, then the chance that the problem is due to fertilization program is pretty low. Macronutrient deficiency can most easily detected in all the leaves, and so you can follow the chart that I showed you in the previous slide, and then do visual diagnosis. Micronutrient deficiency can mostly easily detected in younger leaves. Choose the leaf to sample depending on the deficiency symptoms. So, for example, when nutrient deficiency symptoms are consistent across the field, collect leaf samples from both nutrient deficient and healthy plants, and ideally same age of leaves. The healthy leaf sample can be used as a reference. So it's always good, and because the nutrient level will change over time, and the optimum nutrient range is based on a growth stage. So, if you want to know how severe the problem in terms of nutrient, it's always good to have a reference sample taken at the same time from the same field and compare. And then that way, it will make a lot easier to find out the problem. And tissue analysis is a supplemental plant diagnosis tool, and it does not always identify the problems. So use tissue analysis in combination with visual evaluation of overall plant growth. So tissue analysis data are very useful, but again, they don't tell you whole thing. So I still, go out to the field and then use, for example, overall plant size and greenness of the leaves, and they give us a lot of good information too. So I try to use different tools, and then you can make a better judgment. Because sometimes plants try to adapt to different environmental conditions, and even when plants are not receiving enough nutrients, for example, they might try to slow down the growth, and that way nutrient tissue concentration might not show deficiency, but the growth is stunted. So in this case, tissue analysis will not give you reliable information. And so you really have to look at multiple aspects and then understand that the tissue analysis is just one of the tools. And then again, before using tissue analysis, the step one is always the soil test. So do the soil test, and starting from soil pH, and then make sure that at the pre-plant you applied a sufficient amount of fertilizer. Then you can do tissue analysis during the growing season just to make sure your fertilization program is adequate. And then you can consider, if needed, a foliar application of additional fertilizers. Okay, I think that's it for my presentation. So if you have any questions, here's my number.
My name is Lincoln Zotarelli. I'm an associate professor at the Horticultural Sciences Department at the University of Florida. This presentation focuses on nitrogen fertilizer best management practices for fresh market and processing cabbage head production in Florida, including management strategies that comply with statewide BMP guidelines to optimize economic yield while minimizing nitrogen losses to the environment. The guidelines presented here are supported by field-based research conducted by IFAS and lay the foundation for precision agriculture efforts for fresh cabbage production in Florida. Cabbage is planted in about 9,000 acres with a value of production of almost $50 million. Cabbage is produced in several counties across the state and is a cool season crop. In fact, weather during the growing season is a major driver for yield. Thus, differences in yield are expected between years and even planting dates within the same year. For example, first planting dates around October are characterized by fast initial plant growth, short season, and higher yield. Planting dates during November coincide with lower air temperature and reduced solar radiation, resulting in longer season between planting date and harvest, and relatively lower yield potential. The majority of cabbage fields rely on seepage irrigation due to the predominance of spodosols with a shallow water table. Here's an example of a cabbage field with irrigation furrows spaced every 60 feet, and relying on a water retention structure to manage the water table level. There are also cabbage production areas with predominance of well-drained soil profiles where sprinkler irrigation or drip can be used. For both soil types, cabbage can be produced either on bare ground or plastic mulch with drip irrigation. The commercial production of cabbage under seepage generally uses bare ground hills spaced 40 inches apart and in-row spacing of between plants of 8 inches, which results in approximately 9,600 plants per acre. On well-drained soils, row spacing is generally reduced to 36 inches with 8 inches in-row spacing, giving approximately 21,780 plants to the acre. In plasticulture system, cabbage is generally grown 4 foot wide raised beds spaced 6.67 center to center with plastic mulch and 2 drip tapes. The increasing surface area covered by the plastic mulch allows for a different plant arrangement, spacing and arrangements, leading to an increase in cabbage plant population per area. The response of cabbage nitrogen fertilizers were evaluated for 2 consecutive years. The plant population in this study was 19,600 plants to the acre, and all fertilizer treatments received 45 pounds of nitrogen at pre-plant using an NPK blend, and followed by another 3 subsequent applications at 42, 60, and 78 pounds per acre, totaling 170, 225, and 280 pounds per acre of nitrogen. Note that this is equivalent to 0.009, 0.011, and 0.014 pounds of nitrogen per plant, respectively. The application occurred at 14, 28, and 40 days after transplant. The two contrasting patterns of rainfall occur. In 2016, the cumulative rainfall from transplant to harvest was 10.5 inches, with two major events of 2.3 and 2.4 inches early and late season. The 2017 season was much drier, with only 2.1 inches of rainfall. So the cabbage yield response to fertilizer was directly related to the precipitation within each season. In 16, increase of any rates did not increase total or marketable cabbage yield as seen on table 3. Cows were about 14 to 16%. The lack of yield response to nitrogen fertilizer indicates that nitrogen was not a limiting factor for cabbage in that year. On the contrary, the main reason for reduced yield may be attributed to reduced solar radiation available due to the overcast, dry skies, and low air temperatures during crop maturation. The growing conditions were more favorable in 2017. And in that case, we were able to capture yield response due to the fertilizer application. In 17, there was an increase in total yield with increase of any fertilizer rate. The rate of 280 pounds per acre yielded more than 170. However, 225 yields similar to 280 and to 170 statistically. Marketable yield was significantly higher for 225 and 280 pounds of nitrogen per acre compared to 170. There was no difference in marketable yields for the rate of 170 across years, 2016 and 17, confirming that even when growing conditions are favorable, as observed in 17, 170 pounds per acre of nitrogen fertilizer was not enough to support the potential yield. These results indicate that the cabbage yield might be limited 170, but not with 225 pounds of nitrogen per acre. Another study was conducted using plastic culture. In this case, for 2 consecutive years, with a higher plant population of 31,363 plants per acre. The rates were 80, 200, 300, 400, 500, 600 pounds of nitrogen per acre. That sounds high, but when we get the equivalent of nitrogen per plant, it ranges from 0.06 to 0.019 pounds of nitrogen per plant. Pre-plant granular fertilizer blend was incorporated in the beds using 80 pounds of nitrogen per acre. Fertigation of calcium nitrate was then used to adjust the rates of each treatment. Fertigation scheduling supplied fertilizer increasing concentrations as the plant grows exponentially. The number of fertigations events were 7, in which fertilizer was distributed at 5%, 5%, 10%, 20%, 25, 25, and 10% as indicated by the arrows. So in this graph, you see the cabbage market yield response increased with the increasing rate of fertilizer. So both years in this case were combined. So different weather conditions allow us to investigate the yield response to any fertilizer and determine the optimal nitrogen application range regardless of weather. Maximum cabbage marketable yield, as indicated by the response of the quadratic plateau, was reached with any nitrogen fertilizer rate of 355 pounds per acre, equivalent to 0.0113 pounds of nitrogen per plant. And no additional increase in yield with any fertilizer rates above 355 were observed. The results from the plastic mulch trials are comparable to the bare ground when the rates are expressed on a plant population basis, indicating that a minimum nitrogen fertilizer of 0.0115 pounds per plant is required, and per plant rate can be adjusted accordingly to the plant population. For example, bare ground cabbage produced with 19,600 plants per acre would require a fertilizer rate of 225, while cabbage on plastic culture with a population of 26,136 plants per acre would require a rate of 300 pounds of nitrogen per acre to achieve maximum yield. So the selection of a realistic any fertilizer rate for cabbage is an important decision that will directly impact the yield, economic return, and potential nitrogen leaching. Any fertilizer rate is not the only factor limiting cabbage yield. Other factors impacting potential yield include planting dates, cultivars, soil type, weather condition, disease and pest management, and adequate irrigation. A commercial cabbage head size ranges between 2 and 4 pounds. Oversized heads above 4 pounds are not desirable and frequently refused by buyers. Cabbage yield is limited to 1 head per plant, so increasing plant population per acre is the only way to increase yield per area, and excessive nitrogen fertilizer applications will not increase yield because there is a limit on the commercial cabbage head size, assuring that a required amount of nitrogen is available for plant uptake when needed is critical for a successful nutrient management plan. IFAS has determined that the cabbage plant will require about 0.0115 pounds per of nitrogen fertilizer per plant to maximize yield. Here's the table 3, presents the equivalent nitrogen fertilizer rate recommendation according to the variations in plant population based on row spacing and in-row plant spacing for bare ground cabbage. As the plant population increases, the nitrogen fertilizer rate increases proportionally. And here, the similar table presents the equivalent any fertilizer rate according to the plant population for plastic mulch in cabbage production. Increasing any nitrogen fertilizer rates showed a positive response to marketable yield up to a point, 225 pounds per acre bare ground, 335 for high plant population plastic mulch. At any fertilizer rates above this point, marketable yield stops responding to increasing fertilizer, as we see in this picture, in this figure, reducing net returns and may occur in increasing cost due to the increasing cost of fertilizer. So any fertilizer application timing can effectively reduce any fertilizer leaching in cabbage production because of the improved synchronization with crop demand. The optimal application timing of any fertilizer for cabbage should match the nutrient uptake curve that we see in the schematic on these graphs. In practice, 3 or 4 applications should be considered. For bare ground, applications of 20 to 30% of the nitrogen can be incorporated in the row or at the bed at the planting, followed by 2 additional applications at 6 to 8 inches tall plants and the initial head formation stage. Stop grass, banded or knifed in on the side of the rows with liquid fertilizer. IFAS guidelines for any fertilizer rate for fresh cabbage has been adjusted from 175 to 225 pounds per acre, considering the adjustment by plant population for bare ground and plastic mulch systems. The adjustment will allow cabbage producers to maintain economically viable yields and sustainable operations across production systems common to the Florida vegetable industry, while mitigating water quality impacts associated with over-fertilization, improper timing of application, and high rainfall events. More information about this topic can be found in IDIS HS 1428. I will thank you for your attention.
this invitation. My name is Renzo Ramirez. I am a plant pathology student in the University of Florida. I'm working with Dr. Balat here in the Gulf Coast Research and Education Center. And today I'm going to talk to you about one of the most important diseases in cabbage in the world, the black rot. So in today's presentation, I would like you to, at the end, you will learn about the characteristics of the causal agent of the black rot in brassicas, also the challenges to manage black rot of cabbage in Florida, and at the end, I will give you some information about the research that I'm working with Dr. Balat that is in search of copper alternatives to manage this disease. So to begin with, I would like to mention some information about the brassicas. Brassicas are the third most important group of vegetables that are produced globally, and they have the cabbage as the most important crop within the genus. When we talk about production of cabbage in the United States, Florida is the third largest cabbage producer, and the USDA has registered 9,000 acres of cabbage that produce 125,000 tons of this vegetable, and results in a profit that is very close to $50 million. But just like many other crops, cabbage is also threatened by different diseases, and one of the most important is the black rot. In the case of Florida, black rot reports loses up to 10% of the yield every year. So this disease is caused by a bacteria. The bacteria is Xanthomonas campestris, Pathovar campestris, which I will be referring as XCC. Some important features about the bacteria is that it's a gram-negative and motile. So you can see here in the picture on the left, this was a picture that was taken in an electron microscope, and we can see, give me a second, yeah, here. And you can see here the flagellum that actually helps the bacteria to move. Other important feature is that just like other Xanthomonas species, it typically has carotenoid pigmentation. And this is actually very important at the moment that we're working in the lab, because when we plate the bacteria XCC in a plate, we can recognize it because of these yellow colonies that are going to start growing. Additionally, temperatures around 77 to 86 Fahrenheit and days with fog and rain are very favorable for the development of XCC. Some of the most important symptoms that we can find in cabbage with the black rot, I have divided in two. One is the seedlings and other in the older stages. So as you can see here in the picture above, on the right, you can see a healthy plant that was not inoculated with XCC. And on the left, you see two plants that were inoculated. The characteristic symptom at this stage is the dwarfing and lower leaf drop. In the case of older plants, especially now we're looking at them in the field, we notice that the cabbage has a very characteristic V-shaped chlorothic lesions that are going to appear on the margin of the leaves. But not only that, we also see that this disease can spread into the heads, and internal damage is going to be found because we notice that it's going to be discolorated, and also there's necrotic lesions in the vascular tissue. It is also important to know the disease cycle of the pathogen. We know that XCC is a seed-borne pathogen. This means that it mainly disseminates through seeds. So if we start our season using infected seeds, then we are going to have infected seedlings. However, this is very interesting because most of the time we don't see symptoms in this stage under greenhouse conditions, because first, it's possible that the environment is not favorable for the development of symptoms, but also can be because there's a low concentration of bacteria that is not enough to show symptoms at this stage. Other important source of inoculum of the bacteria is that they actually survive in plant debris. There has been research done, and they have concluded that XCC can survive in Brassica debris for at least 2 years. And when the environment is conducive, the dispersal by rain and wind and also the water splash can take this bacteria to our susceptible host. Once in the host, the bacteria is going to enter the plant through natural openings that are located on the margin of the leaves, which are called the hydatodes. And after that, it's going to start infecting and colonizing the leaf and vascular tissue systemically. Around 14 days after the infection, we're going to look at the development of lesions on the leaf, and afterwards, bacteria process is going to go into the stem and the roots, and we can see xylem decay. Now, knowing about the disease cycle is very important, because knowing that, we can actually target management tools. So, for example, we know that XCC can survive in plant debris. So in order to establish some management tools, we have crop rotations. We know that XCC is not only restricted to cabbage, it can also affect other brassicas like cauliflower, kale, and even brassica weeds. Especially brassica weeds are one big source of inoculum, especially when we have next to our cabbage field this weed, the wheel mustard. Under good conditions, the bacteria that is growing here can just spread into our cabbage field very easily. Additionally, we know that XCC is a seed-borne pathogen, so it's recommended to use certified disease-free seeds and seedling, and also use resistant varieties at the moment that we start our season. Now, we know that at the moment that we start looking symptoms in our field of XCC, the first product that comes to our mind, it might be copper. Copper has been used for many years to manage bacteria diseases. However, in the case of the Florida industry, there is a concern about the appearance of copper-tolerant strains. There has been reports in Florida about the appearance of Xanthomonas citri and Xanthomonas perforans, copper-tolerant strains. And what these strains are going to do is actually do the work of the grower even harder, because they need to elevate the rate of copper that they put in their field. But not only this is a problem for the budget of the grower, it also can lead to environmental effects, because this copper can be accumulated in the soil after constant applications. So we have identified the most important challenges to manage the black rot in Florida. First of all, Florida's environment is ideal for black rot outbreaks. We know that Florida, for most part of the year, is typically humid and warm. So this actually is very favorable for the disease cycle of XCC. Additionally, growers basically relied mostly on copper-based products. And by just using and relying on copper, we're creating a high selective pressure for these copper-tolerant strains that are going to make the management even harder. So taking that in consideration, our main objective is to determine the efficacy of copper alternatives to manage the black rot in cabbage. So what I'm going to start doing now is talking about the research that we are conducting here in the Gulf Coast Research and Education Center. For this set of trials, we always use the cabbage cultivar Bronco. We grow it here in our greenhouse, and then we transplant it into the fields. And we wait in the field until the cabbage is in the pre-cupping stage, as you can see here in the picture. And then we start the application of the treatment 7 to 4 days before the inoculation. After that, we continue the treatments applications weekly for 5 to 6 weeks. The inoculation was done using a backpack sprayer with a bacterial concentration of 5 times 10 to the 7 CFUs per milliliter, and it was performed twice in each trial. In the case of the evaluations began 10 days after the inoculation, and it was we did weekly ratings of the plants, looking for the percentage of disease severity in each of them. At the end of the trial, what we did was calculate the area under disease progress curve. This is a summary of disease over time that is going to tell us how much disease we get at the end of the season in each treatment. Finally, we perform a harvest. The harvest was done manually, and each of the head was weighed and cut in the half in order to look for internal black rot symptoms, as you can see here in this picture. So anytime that we look for these symptoms in during the harvest, we didn't take that head in consideration to calculate the marketable yield. So today I'm going to present the efficacy test that we performed, and I have separated in two groups of products. First, I'm going to present the sulfur and plant defense activator products that we use. So we started this trial to determine the efficacy of products in alone and mixed applications with sulfur, and then we want to compare the results with a grower standard and a not treated control. Other set of trial was we want to use the surfactant as a treatment to determine the effect of weekly application of surfactant in the black rot severity. So we know that XCC likes watering conditions, likes to stay in the leaf when there's free water. So we were thinking that the use of weekly surfactant without any product was actually going to increase the disease severity compared to the other treatments. In all the treatments that I'm going to present, I use COSI 3000 as my grower standard. Its active ingredient is copper. Also, I use plant defense activators like Agehara, Baxiplant, Howler, Lifeguard, and Regalia. Additionally, we add Mancozeb, especially in a mix with copper, because we know that it's one of the products that growers use at the moment of manage bacteria, especially in tomato. And finally, the sulfur-based product, mycothiol. You might be surprised that we're using sulfur to manage bacteria, but because we usually use it to manage fungal diseases. But in this case, we have reports from especially growers that they start adding mycothiol in a lawn application or in tan mix, and they have reported very good management and improvement in the management of the black rot in their fields. So taking those reports in consideration, we want to add this product to our trial to see the efficacy against other products that we have. The second set of trials, we use biological products. And in this case, we want to determine the efficacy of these biological products compared to a grower standard and an affiliated control. Additionally to the products that I mentioned before, we also add other plant defense activators like Razox, Stargus, and Theia. And also we add Serenade Opti, which mode of action is more targeting the disrupting the cell membrane of the pathogen, and also having an inhibition in the attachment of the pathogen to the leaf. So the first set of products is focusing on sulfur and the plant defense activators, and we're going to focus in these 5 products: Agehara, COSI, mycothiol, Mancozeb, and Baxiplant. The rates that I'm going to present here and the rates for the upcoming trials were selected looking for the most for the higher concentrate, the highest rate in the label, but also considering the rates that the growers use in their fields. So during the first trial in the spring, we only focus in 3 products: Agehara, COSI, and mycothiol. What you're looking here is the area under disease progress curve, the AUDPC, which is the amount of disease over time. And we noticed that Agehara and COSI, both of them significantly reduced the disease severity compared to the not treated control. On the other hand, the sulfur product, mycothiol, didn't show the same significance reduction when we compare it to the not treated control. When we looked into the yield, we noticed that there's no significant difference between the treatments. However, there is a marginal effect of COSI 3000 improving the yield compared to the other treatments. During the fall of 2021, we used the same products that I mentioned before: Agehara, COSI, and mycothiol, but we add Baxiplant and we add Mancozeb. With not only that, we also add treatments where we mix microthiol with Actigar, the same microthiol with Cosai, and the same with Baxiplan. We also made a mixture of Cosai and Pencosep to see the efficacy of this product. When we compare the products to the not hidden control, only Actigar and Cosai, both of them significantly reduce the disease severity. And however, microthiol, once again, we notice that it doesn't have a significant reduction on the disease severity. But this graph not only gives us that information, it also shows us how the mixtures of microthiol with the other products doesn't really improve the efficacy of the alone application. For example, here with microthiol and Actigar, we see that there's no significant difference between both of them. The same happened with a mixture of microthiol and Cosai applied alone, and the same happened with Baxiplan. Once again, we didn't see significant difference in the total yield when we compare the treatments. However, here we start looking for something very interesting. As I mentioned at the beginning, we calculate the marketable yield. The marketable yield here in this graph, you can see it in these blue bars. And the total yield is the orange bar here in the graph. So whenever we find in the harvest plants that have similar symptoms to this picture, we didn't take it in consideration to calculate the marketable yield. And we noticed, and even though there's no significant difference in the total yield and in the marketable yield, we noticed that some products are actually reducing the yield during this season. This is something that we saw in subsequent trials. However, it was not consistent. It looks more that it was very sporadic, because in this case, we noticed that it's Cosai, the combination of Cosai with Pencosep, microthiol with Baxiplan that shows reduction. However, in subsequent trials, we noticed that these products actually perform similar when we look for incidence in the head, in internal symptoms of the head. So we are like thinking to make more evaluations about it, but we also believe that this reduction is caused more by environmental factors, also of timing, and also is caused by timing of inoculation. So we're gonna continue working with this in the upcoming seasons. So some important points to remember for this first part is that Actigar was very effective alternative to copper to reduce the black rot disease. Also, microthiol showed no beneficial effect reducing disease severity or improving the yield, apply either alone or in tan mix. Also, there was no significant difference among the treatments in total yield or in marketable yield. The second set of trials that we conducted were testing the biological products. In this case, we're using our grower standard, Howler, Regalia, Raysox, Serenade Opti, Stargus, and Theia. In this case, we did things a little bit different because we didn't mix all the products. For example, here in the case of Raysox, we use an alone application of this product, but we also alternate with Stargus. This means that 1 week we only apply Stargus, and the second one we use Raysox. The only case that we did a mixture was when we mixed Regalia and Cosai, and after that we alternate weekly with Stargus and Cosai. As you can see here in this graph of the AUDPC, compared to our not hidden control, all the treatments reduce the disease severity. However, once we start comparing the products against our grower standard, the copper product, we see that some of them have similar or even better effect reducing the disease. And this is the case of the alternations of Regalia mixed with Cosai and Stargus with Cosai, the application of Theia, Race, and Raysox. So the points that I want you to remember from here is that all the treatments reduce the disease severity during the fall trial that I just presented. And we also have a second trial that we have conducted, and it was only Howler, the product that significantly reduced the disease severity compared to the not-yielding control and also the grower standard. And once again, in here, there was no significant difference in total yield or in marketable yield. The last set of trials that I'm going to present today is adding the surfactant. We use dynamic, and we select the products which had better results in previous trials. In this case, we focus on individual sprays, but we only have mixtures of COSI with microthiol and Pencocept. And one more time, we noticed that during this season, all the treatments significantly reduced the disease severity compared to the not-yielding control. But once we start comparing with COSI 3000, we found out that there are some products with similar or even better efficacy, like Actigard, Howler, Baxiplan, and Regalia. Something that was very interesting and we were not expecting was find that when we use the surfactant, actually it has the lowest disease severity compared to all the other treatments. In this case, we found significant difference in the total yield compared to the not-yielding control. We noticed that products like COSI 3000, Howler, and Regalia significantly increased the yield. And it was very interesting to find that the product Actigard, it doesn't have, even though it has the lowest disease severity among our treatments, it didn't actually improve the yield of the cabbage. So just to remember, in this case, all the treatments reduced disease severity compared to the not-yielding control, but only it was improved in the yield when we use COSI, Howler, and Regalia. So the take-home message that I want to give you after you listen to all these trials is that for the black rot management, that we have identified some potential copper alternatives, such as Actigard, Howler, Regalia, Razox, and Theia. But we also have unsatisfactory performance coming from microthiol applied alone or in mixtures, when we only apply Pencocept alone. Also, when we combine the improvement in the yield and the disease control, the best products that we found were COSI 3000, Howler, and Regalia. So our research is still in progress. Actually, we're looking forward for some future work that is going to be conduct trials during transplant production. We want to see the efficacy of some of the products that we use, but in greenhouse conditions. Also, we want to evaluate cabbage varieties for resistance to black rot, and we're working on the characterization of XCC isolates that we have collected in Florida production fields. Just to conclude, I would like to thank my advisor, Dr. Gary Balad, and all the lab members of Balad Lab for all the help through these years. I know that it has been hard, so thank you very much for all the help that you have given to me. And if you have questions, please do not hesitate to contact my advisor, Dr. Balad, or myself. We are going to be very happy to answer all your questions. Thank you.
Actually just going to be talking about Diamondback moth and brassicas. There are a lot of other pests in brassicas, but Diamondback moth is really the one that gives us a problem. So I want to just start off talking a little bit about the treatment interval approach to managing insecticide resistance in Diamondback moth. Diamondback moth is a problem in Florida and globally because it develops resistance to insecticides. When you apply just about any insecticide, you can assume that a certain proportion of the population in your field may have tolerance to that. Some females may survive, will produce offspring, and will pass on that genetic tolerance to the second generation. So what you don't want to do is treat successive generations with the same modes of action. So we use a 30-day treatment interval, which corresponds roughly to the generation time of the diamondback moth. They spend about a week as eggs, a couple weeks in the larval stage, and about a week in the pupal stage. And you'll actually see a 30-day treatment interval on some of the labels that you can apply the same modes of action more than once within that 30-day treatment, but then in the next 30-day interval, you need to use different modes of action. So here in this schematic, I've started off at the early establishment of cabbage crop and broken it up into 3 30-day intervals. You don't necessarily have to start applying insecticides as soon as the cabbage or other brassica crop is in the ground. If you're growing brassicas in Florida in the fall, you may not have problems with diamondback until a few weeks into the crop, and you might not be applying until you're in these early, say early cupping stages. And you might want to go ahead, say with some of the better insecticides that we've evaluated over the past years, you might want to go out with Proclaim, Radiant, Zentari. And if you apply them in this what would be this mode of action group in the middle here, that's fine. But then when you get to the last mode of action group, as we're approaching harvest, you wanted to use completely different insecticides such as Torac, Dibrom, and Avant. Now, if you're growing brassicas in the spring, when we consistently have high diamondback moth pressure, you might want to start off with an at-plant treatment of a diamide, say Coragen or Verimark, because they're systemic and will have that extended effect. Since it is systemic, you probably only want to apply a diamide once. Whether you apply it once or twice in that first treatment interval, you don't want to apply it again in successive treatment intervals. So that's the way that concept works. Another thing that we want to keep in mind is the relationship between the crop phenology and the insecticides. When I started working 5 years ago with diamondback, I assumed the diamides were the most effective insecticides for diamondback. We're talking about Coragen, Verimark, Exorel, Arvanta, because they have this systemic action. They're really the only systemic insecticides that are effective against diamondback. Movento has diamondback on the label. It's the only caterpillar on the Movento label. I have not worked very much with Movento, but really when we're talking about systemics, particularly with something that can be applied at plant to the root system, we're talking about the diamides. So the question that I was wondering, growers were wondering, early on, when do we want to take best advantage of that systemic action? Is it early on? Because when the female goes into that growing point, you see in that early plant, lays an egg, the larvae carry out feeding on that growing tip of the plant, it's destroyed and nothing is going to be harvested. So is that when we want to use our best materials? Or do we want to use them later on when the head is starting to form and when a contact or even a translaminar material might not really penetrate to where we want to get? So this is a question that we're going to get back to a little bit later, the optimal placement of diamides. And just to be clear, the diamides are the group 28 insecticides. They're ryanodine receptor agonists, Coragen, Verimark and Exorel are the same active ingredient, cyanotroniliprole. Harvanta is really only can be applied to the foliage. And I've listed some of the combined products down there that have diamides in them mixed with other modes of action. When I started working with folks at the University of Georgia in about 2018, we carried out a maximum dose bioassay that was developed by Stormy Sparks and David Riley, in which we used the top labeled rate of a range of insecticides against field collected populations to try to clarify patterns of resistance in Florida and Georgia. And this is a publication that we put out in 2020, which I'd be happy to send anyone who's interested. And here's a figure from that publication showing some patterns for chlorantraniliprole on the left, which is Coragen, cyanotraniliprole on the right, at least as I'm facing it. And really what I wanted to show you with this map is the main Brassica area growing areas where I have been working. So you can see up Tri-County area, up St. John's, Flagler, Putnam, down where I am here in Hillsborough, Manatee. And we've also collected and tested from a variety of farms around Lake Okeechobee. So it's a pretty simple test. We would just mix up the top labeled rate in the equivalent of 30 gallons per acre. We would treat a cabbage disc. We would weigh the disc because we're also getting information on feeding. Then you can see we would take second or third instar Diamondback from somebody. We would get populations from the field, rear them through the next generation in the greenhouse, place them on that disc, and then give them 72 hours to feed. And after 72 hours, we would look at mortality, and we would also see how much feeding had been done. And this would be replicated 4 times. So this is a table that I presented a couple of years ago, or started presenting last year, at least maybe at the Citrus Expo. And don't normally like efficacy tables, but we've worked enough on this that I'm comfortable with this. And you'll see, I'll show you some of the populations that are behind this table, basically. And these are patterns we've seen in Florida and in Georgia. We've consistently seen good results with Proclaim, Radiant, Zentari, have looked less at Diabrome, but good results. Torac, I just moved from the Citrus Expo meeting a couple of days ago up to the high group from the intermediate group, and you'll see in some of the populations it does perform consistently rather well. The ones in green and the percentage mortality there, when it says above 74% or 71 to 61%, that's from the paper with David Riley. With Harvanta, with Veromark XRO, we've had variable results, as you will see. Dipel is fine. We've consistently seen better results with Zentari, and there are a lot of other BTs, but those are the only 2 I've looked at. Avant, you will see, is never the best material. It is also never the worst material. So Avant, I think, is a good rotational partner for Diamondback. With Coragen, you're going to see quite variable results. Initially, looking at Lanate did not work well. Same with the pyrethroids, which we, on the whole, do not recommend for Diamondback. I was involved in generating some of the data for NAC a number of years ago. We do have a special label for NAC for Diamondback, but it has never really stood out as a Diamondback material, and neither has Ryman. And I think my screen's a little concealed here, but Intrepid should be down there on the bottom. Reached out to Dow about Intrepid years ago when we started doing this, when there still was a Dow, and they were very clear on the fact that Intrepid is not particularly good Diamondback moth material, that Radiant was their good Diamondback material. So I want to show you some representative populations going back from the past 4 years of this maximum dose assay that we've done here. And we collect populations, or our collaborators have helped us collect them. Glades Crop Care has been particularly helpful in this. And we bring them back, we rear through to the second generation, and we test those second generation larvae in the lab. And here are just 2 populations from Hardee County, and you can see the percentage survival after 72 hours. The blue column is the control. Usually want to see that over 80% to feel confident in the test. So what I want you to see are those very tall yellow columns of Lanate. We consistently saw Lanate really not doing much of anything. The red column there is Brigade. This is the main. We looked at Brigade and I think Warrior, but the pyrethroids were consistently not very good. You can see Dipel in there, Intrepid, also not very effective. We really stopped looking at Intrepid after this year. Coragen is the light green column in the middle. And this is the sort of pattern we started to see pretty early on, that it was, we've got 50% survival. And these larvae are stuck in a petri dish with nowhere to go and nothing else to feed on. And yet half of them are still alive 3 days later. And as you go looking towards the right, what you're going to consistently see, we have a bright blue for Proclaim, we have pale sort of gray for Zentari, black for Radiant. Those products are consistently on the right where things are doing an effective job. And in this particular season, we did get good results from Harvanta on these populations, and variable with XRL. So here are some populations from 2020. Again, we couldn't test everything all the time, but focusing on the diamides, seeing not particularly good control with that for that Charlotte County population. If you look at the the transplant production, this is from a large-scale transplant production house in Sumter County, and you can see there was complete failure of the 3 diamides. There were actually more Diamondback surviving where we treated them with Coragen than where we didn't do anything. Hervanta, Exerel, so real complete failure of all diamides. And we would see this, and actually we're advising people really against using the diamides just because this was a pattern. But what is also interesting, you'll see when the diamides aren't really working, you're looking over to the right, you're seeing good results, Radiant, Proclaims, Antari, and with some of these other materials. Some more populations from 2020, poor performance of diamides, or again, from that Charlotte County, a different farm. These are all commercial farms, complete failure of the diamides, reasonable results with some of the other materials. And one last population where the diamides did very little, but Proclaim, Radiant, and Thorac killed everything. So I want to switch gears a little bit and talk about some work we've been doing to starting back in 2018, trying to understand the best placement of these diamides back when it seemed that they were more of the optimal products. And a grower here in Manatee County was knifing Coragen and Verimark in a few weeks after crop establishment as a way to have the product be taken up by the roots, because it is, of course, systemic. Now, there was some talk in a previous presentation about cabbage under plastic. Most cabbage is grown bare ground. So if it were grown under plastic with drip, you would have better luck, at least delivering the diamides to the root system. But I was wondering, is this actually an effective way to deliver Coragen or Verimark to the root system? And as it turns out, DuPont, back when there was a DuPont, they did this work. And what I want you to look at in this slide, which was provided by DuPont, in those squares, what you're looking at is the movement from a drip irrigation. The little blue circle is the drip tube, and they collected data on the movement over 14 hours of Vidate and AdmirePro and Coragen. Now, Vidate and AdmirePro, imidacloprid, like a lot of the neonicotinoids, is quite these products are quite mobile in soil. But the point that I want to make with this is that the diamides are really not very mobile in the soil, and this has already been proven by the manufacturers. So if you're thinking of knifing Verimark or Coragen in with the hope that it's going to move with that gradient towards the root, it's really not going to work. These products, the diamides, are only effective if they were really delivered directly to the root. And in recognition of that, the cyanotronilprole Verimark actually has a nursery application label. It can be applied in the nursery up to 72 hours before being shipped out or going into the field. This way, here you've got a picture of it being applied with a boom. In theory, a grower could do this. We've done it on a small scale to evaluate this to see, is this way of applying cyanotronilprole Verimark effective in terms of giving a longer term residual efficacy as opposed to, say, doing it at planting or foliar. This is some work done by a master student, Esnai Muntali. You can see her picture there, graduating last month. And what we looked at, and we did this actually a number of times going back to 2020. I'm going to show you the last 2 times we did it, which I think were the most, we weren't disrupted by COVID or anything like that. But we have looked at this a number of times, and we looked at 8 different treatments, or 7, including the untreated control. So what we looked at, we treated cabbage with Verimark in the tray. We treated cabbage with Verimark or Coragen at planting. And we had foliar applications of either Exerel or Coragen 3 weeks after planting, and either Exerel or Coragen 5 weeks after planting. So each plot just got one of these treatments. And then what we did is we took the plant tissue and we fed it to a highly susceptible lab colony to see how long those caterpillars would die. The logic being, if they die, it's because the insecticide is still there. And if they don't die, it's because it's not there. And we used a lab colony, unlike the data I showed you before, which was from field colonies, which that wouldn't have worked because there's a lot of resistance in the field. So again, just to emphasize the way we did it, you can see the tray treatment. You can see us ladling the at-plant treatment, which is a lot more precise than in terms of the amount than what you might get with a drip, an actual drip application, but we're trying to be precise. And you can see there were 2 foliar applications, one at 3 weeks, one at 5 weeks, in which the plants received either XRL or Coragen. And to sample, initially we would take the whole plant because there's not a whole lot there when we would provide that to the caterpillars. And just got some images here. We were always trying to be consistent and sample that innermost sort of tender growing central part of the plant where the female diamondback at least most like to go in and lay eggs, and where you really consistently find those early infestations on the plant. And as I said, we used a highly susceptible colony. It was from Delaware. We got the eggs a week before, as I would rear them out on plants in the greenhouse. And the following week, when we had those second or third instars, we would put them out and do the test. And we'd look at 72 hours to see if they were alive or dead. And we also took information on feeding, with very striking differences with some of these treatments about the amount of feeding. So we took data every week for 10 weeks, but I'm going to pool some of those data just for simplicity's sake. So what we're looking at here is survival after 72 hours from the 2 runs of this experiment, from fall 2021 and spring 2022. And what we're looking at is the number of larvae that survived after 72 hours. And we've got the control, where everything was pretty much fine. You can see Cyanotronilipol tray, which is the Verimark in the tray. You've got Cyanotronilipol plant, which is Verimarket plant, and you've got the Coragen plant. So you can see that the tray and the at-plant treatments pretty much killed everything those first 3 weeks. A little bit of difference the second year with the Verimark, but they pretty much killed everything. And then at week 3, you can see we applied these foliars. We applied Coragen in some plots and XRL in other plots. And what we're looking at here is the two weeks after that application, averaging. So weeks 4 and weeks 5, we collected it. I'm just showing you the average of those 2 weeks. And you can see that everything's doing better than the untreated. There's continuing to be a residual effect, but the tray treatment is at this point no different from the foliars, which were not as good as the ones that were applied at plant. So that's kind of striking that we're continuing to get the suppression from the at-plant treatments. Lastly, we applied Coragen or XRL in a different set of plots 5 weeks after, and that's what we're looking at here. So we applied those last ones week 5, we collected samples week 6, 7, 8, 9, and 10, and that's what we're looking at here, the average of 5 weeks, the last 5 weeks, pulling it all together. And again, I should say when I started this, I assumed that a few weeks after these treatments were applied that the material would break down, it would become too dilute in the plant, and things would start looking like the untreated. Nothing ever approached the untreated. It's some of the very last weeks with some of these, if you looked at it week by week. But we saw much longer residual efficacy than we expected from all of them, and a much greater impact. I mean, you can see those 2 at-plant treatments were still 10 weeks after application. We're still killing a lot of these, most of these larvae. And remember, this is a highly susceptible lab colony. I'm not saying you're going to see this sort of control in the field, rather the opposite. So what we're seeing, and I am assuming this is analogous to diamides not being mobile in the soils, we're seeing, at least in cabbage, these materials being retained, that we're seeing a much longer residual effect than I was expecting. And I'm assuming that for a field population, these are sublethal doses. So what you're kind of doing is feeding sublethal doses of diamides to field populations, which to me helps explain why we see these problems, why we see this resistance. It's just retained in the plant for much longer than was expected. And we sent some to a lab in Canada for analysis, those at-plant treatments. It's very expensive. I was only able to send the at-plant ones, but indeed 10 weeks after planting, they still were detecting diamides. So something else just to think about is the feeding. We're taking data on feeding, and I'm going to pool the 2 years just for simplicity's sake. So going back to that first 3-week interval, you'll remember all the untreated were alive and pretty much everything else was dead. Well, they fed quite a bit before those 72 hours. So not much of a difference amongst treatments, nor much of a difference between the treated and the untreated. I mean, it is statistical. There was statistically less feeding, but still not a huge difference, indicating that they do feed quite a bit before they die. And we're seeing the same thing. This is that next interval. We were looking at weeks 4 and 5, where we've got those 3 foliars. None of these treatments are really separating statistically in terms of the amount of feeding suppression, whether they were applied at plant or much later. there aren't huge differences with the untreated. And that last group, when we're looking at the last month of the crop leading up to harvest, the lowest really is still the Verimark at plant in terms of reducing feed in. It's not statistically different from the Coragen at plant or the 5-week XRL. And one of these, the Coragen 3-week, was not statistically different from the untreated, but it's important. We usually just think about mortality and what is killing the caterpillars, but with a lot of these different treatments, we've seen quite a bit of feeding before they died. So in wrapping up, I want to go back to the maximum dose studies that we were doing again this spring. And I just want to say that we actually saw a slightly different pattern with some populations compared to what I initially showed you from those first few years. This is some of Amanda Faruya's master's work. Amanda looked at diatomaceous earth alone and in combination with the BTs, that is in combination with dipel and with Zentari. A grower reached out to me a number of years ago, and I was finally able to look at this. I mean, so the diatomaceous earth is the gray column. If you look at the cabbage from Martin County, there's only 40% survival, which was kind of promising, but more often than not, what we saw was what you see under the Palm Beach County population, which is a little bit of something happening, but not really very much. Diatomaceous earth is normally used as a stored product material. It abrades the outer, the cuticle of the insect and causes it to dry out. But we looked at this as a feeding test and in a spray tower, did not see really promising results either alone or in combination with the BTs. But the other thing that you can see by looking at these figures is not very tall columns. We started looking at lanate again. That first graph I showed you from 2019, lanate was 80% survival. Brigade was 80% survival. But look, these populations were actually pretty much susceptible to everything, including lanate, including pyrethroids. You can see all of the diamides worked reasonably well or quite well. So you can see we looked at Spearlep combined with Leprotec a number of times this season because there's been a lot of curiosity about that product. And, and you can see that in some of these, it worked reasonably well, that combination of the two. So I just wanted to say we have seen some more susceptible populations, and this is corroborated by the good people of Glades Crop Care who submitted a lot of these. They were also saying, yeah, a lot of these weren't that hard to manage. However, we are also still seeing populations that do have pretty significant tolerance to the diamides. This is also from the spring. You can see the gray columns there, the diatomaceous earth next to the untreated, not really doing much of anything. But you can see XRL and Coragen. We did not look at Harvanta, but XRL and Coragen not working particularly well or at all in these two populations. But some of these other products, as we'd seen previously, Proclaim, Zentari, Radiant, Torac, Dibrome, working quite well on populations that are tolerant or resistant to the diamides. So yeah, that's all I wanted to say. I wanted to thank the funding sources for this work and also thank the people from Glades Crop Care as well as the people in the lab who helped do the work.